Well, I found this wiring diagram, and it says it goes from, the filament string goes from the tube 35W4 pin 4, and all the filaments are wired in series, and the last one is pin 3 of the 12AV6. Or yeah, pin 3 of the 12AV6. Pin 3. Kind of funny that ain't staying still, but it could be loading a capacitor. That's what I think's happening, is it's charging a capacitor in the circuit somewhere. But there is continuity all the way through all the filaments. Woohoo! So the filament string's okay. So I guess the next thing to check would be the can you come off of there now? There we go. I think the next thing to check, I think the next best thing to check is probably going to be the, well, what's not replaceable. The volume pot, the length of it, I could probably get a new one of those, but I'll double check that. The coil for the transformer coil or whatever it is for the speaker, and then these right here need to be checked too. Make sure this is, because if this is no good, then I think the whole thing is just junk. Can't complain for free though. Can't complain for free. So I'm not sure what's what on this, so we're just gonna pick two. Oh, wrong two. Where's that going? This isn't good. No continuity. Might not be making a good connection right there. That wire goes to there. So we might get a good connection there. So make sure we're not on hold. The meter is working. There we go. .3. So that's between this one and this one. I don't know if you can see, my hand's probably blocking you. That's between this terminal and this terminal of this transformer coil. So the other two are here. Hook it onto that one. Get that off of there, and we'll hook it onto that one. Looks like 6.9. They have continuity, that's all I care about. I don't know what they're supposed to be. I'll look on the schematic in a few. So this one's red, red, green is that resistor. Might as well check it while I'm right here. Red, red. So that would be 2, 2. Green would be 5. I think this is going to be over. I always got to use a calculator to do this. I can't do it in my head. 2, and the multiplier is 5. 1, 2, 3, 4, 5. 2.2 megs. This meter only goes to 2,000 or to 2 megs, so it's a little bit too much for this meter. And there's no identifier on it, so no tolerance. So that's a 20%. We can be as high as 2.64. 2.64 megs. Let me grab my other meter. Yeah, I don't think you're going to be able to read that. I'll hold it up for you. I don't like this meter because between voltage and continuity, or ohm meter, you have to move the lead. That has screwed me up so many times when I'm when I'm working on something and going between continuity and voltage. I forget to move this, and then I go around in circles. But this does go up to pretty high in the meg range. So, wow. There we go. 2.2. That's right on the money. I don't know if you can see that. Yeah. Look at that. 2.2 megs. Can't get any better than that. Alright. Let's spin it around. We can take a look at this. So the red, there's 2 wires on it, a red and a blue. Red and blue. I suppose we could check this coil, the voice coil. And it doesn't look like there's another. Yeah. It goes to the headphone jack. You look at that, it's almost it's charging a capacitor. So 0.5, 0.4, it's right on, it's got continuity. I don't know what the resistance of that voice coil is supposed to be, but it is there. Oh, I got the meter out. Let's check that light bulb I removed. See a lot of the, I don't know what they call that, the tungsten burning off, going to the outside of the bulb. It's not necessarily means the bulb is bad, it just means it's got a lot of hours on it. I don't know if I'm going to be able to do that with these. They don't stick proud. I know. I should be doing something else other than this, but I'm curious about this light bulb. Nope, open. Light bulb's bad. Burnt out. Alright, enough of that, huh? So the red and blue wires go through the chassis in this corner. So let's spin it back around so we can go to the other end of it. I'm wondering if we could hook it up to the output of one of my, probably to my signal generator. Have the audio come out. I might try that. So I think I spun it this way. Red and blue coming through the hole of the chassis. And of course there's red and blue on the, they're coming through. Yeah, they're coming through under that, under this blanky blank thing. Doesn't look like this is actually tied in there and it's just stuffed in. Let's see if we can get that out of there without damaging anything. Yeah, it's stuffed in there behind that capacitor right there. There we go, red and blue. Red and blue. The lighting isn't so good for that camera, is it? You see the red and blue coming through there. Looks like one goes to that terminal right there. And then the blue one sneaks all the way over to this terminal on this tube. Let's see, it goes to, looks like that terminal right there. Looks like we have 223 ohms. 223 ohms. So the transfer coil, the speaker transformer is okay. I guess there's no way to really check the secondary windings of it because it's this speaker probably has less resistance than the coil. So hooking it up to the signal to one of these generators up here, I don't think this signal tracer voice coil output works. We can try it. We know where they go. We can use these to put the power to them. Which one should we try? Signal tracer? You want to try the signal tracer, my old Knight signal tracer? It says it's got a voice coil up there. Will these plug into that? Sure enough. Alright, let's turn it on. Let's see the magic eye come on. Let's hook the ground in first, right? Nothing. Yeah, I didn't think that worked. I'm gonna have to investigate that. Let's go to the signal generator. Let it warm up for a minute. And I think these plugs are too big. I think those are the smaller banana plug connectors. But these might fit in there. Might be able to make connection. It's working. So the speaker works. This little test equipment's pretty awesome. Let's turn that back down, turn that back to RF, and turn it off. Alright, so we know the speaker transformer is working. We know this transformer coil is okay. I guess the other thing to check would be the speaker, the filament string. I guess we could check this switch too, this special, make sure that switch is working correctly. And then make a list of capacitors we need, and then check resistors, but I'm assuming they're going to be okay. I don't know, these high ones seem like they're, I don't know. Yeah, I don't know. Let's get the meter back over here. Plug it back in. Continuity. Come on, let go. I don't know what this pot is supposed to be, but we'll measure the overall first. So it's 500K possibly. This is showing 400K. Oh. I would not. Yeah, 400K. Alright, so let's turn it down all the way. And let's go to the sweep. So down all the way is 4.4. And it is slowly going down. I don't see any bad spots yet. Just the meter just auto ranged is all. It should auto range again here and blink out pretty quick. Yep. It auto ranged again. So we'll turn it back up. Auto ranging, auto ranging. And what I generally see when there's a bad speaker or a volume pot, it'll jump, you know, the numbers won't rise consistently. It'll go to, like, let's say 2, like right now it's at 214K. And then if I turn it a little bit more, it might jump back, right, to 180K, and then I turn it just a little bit further and it'll jump up a little higher, like 2.29. It'll skip around, and this is really not doing that. This volume pot seems to be okay. I don't know if I'll spend any time cleaning it. It looks like it's okay. Once we get it running, we'll see if it's, you know, what kind of noises it's making. I'm wondering if it'd be okay to plug this in. Not really seeing. I know this is an old paper electrolytic, but I'm not really seeing anything wrong with it. I mean, it can't hurt. What's the worst thing it can do? There is no transformer to blow up. Like on an older radio, you blow the shit out of the transformer. Alright, well, let's check that. I guess we could check the IF cans coils. I guess that's, you know, if those are bad, we're not going to be able to replace those. So they look like they're fairly easy to get to. Yeah, one there, one there. I hope they don't have silver mica disease. If they have, so I ain't messing around with taking those apart. Boy, that seems awful high in the M range for an IF coil. I wonder if that IF coil is open. How could I be backfeeding to this? Let's check the other side. Oh, that would be a bummer if that IF coil was open. Okay, that's a direct short. That is in the... It's not looking good. Yeah, it's the connector. Okay. I got fairly good connection there. Not liking that. That IF can might be open. Not looking good for that IF can. I don't know what the heck that's all about. It should be, I would think, around 25 to 70 ohms. See if the schematic gives us any information. The schematic showing them as 16 ohms. Well, that's not good. That IF can's bad. Let's check the other side of it. Oh, they might go this way. Nope. Nope. Something's not right here. What are the chances of both sides of the can being blown? Alright, where's the other one? Right here. This one's got 2 terminals. This one has 3. Huh. The schematic don't show them as having 3 terminals. The one side does. Oh yeah, 6 terminals on the one. There's 2 capacitors built into it. C11 and C12, pin 5 and 6. So between 4 and 3 and 1 and 2. Are they numbered? No, why would they number them? Yeah, you don't need to number them. What are you thinking? It's not like somebody's going to work on it. So nah, that can't be right. There's 16 ohms. That's across this way. So I thought I measured that one this way. There's 16 ohms. Wow. So that means this one's got to be 16 ohms too. $16 ohms. So that IF can's not bad. Okay, there's one side. Center terminal. Yeah, that's in the M range. Alright, I'm done with those things. Let's get the gold-plated ones in here. Need my relief pitchers. Send in the lefty. That's in the M range on that. Alright, RF cans are okay. That's 15 ohms. Sometimes it's easier to get in there with those. So the IF cans are okay. I guess check the switch. Special broadcast. Maybe we'll go back to these guys and get them in there pretty easy. So that side's okay. Does it turn off? Yep, opens. Closes. Now that should be open. No. Huh. Well, let's see what that switch looks like on the schematic. Yeah, backfeeding from through the antenna when I switch it. It's always got a little bit of continuity between pin 2 and the power through this coil, through that little transformer. So I'm not going to worry about that. It looks like it's working. Oh, these old fucking hard wires. Just junk. Junk. So that switch appears to be working as well. Yeah, I don't think there's too much more to check. I don't know what that is. Is that some sort of capacitor? Inductor? Choke? What the heck is that? Is there a capacitor? Huh. Alright. See if I can get that clock to work. Maybe I'll plug this in a minute.